sheet of neurons at the back of each eye, and those neurons have standing electrical potentials, makes each of your eyes like a bar magnet. You know, the bar magnet. You know, you put the paper on top of it and the iron filings, and it makes those wavy lines. Did you see this in high school physics, maybe? A little bit of that? Look it up on YouTube. There are great demonstrations of this. But essentially, fields of magnetic flux that flow out of the North Pole and back into the South Pole. And the idea, of course, with the bar magnet is as it moves, those fields of magnetic flux move as well, and they influence things at a distance from the magnet itself. If your eyes in their orbits are like bar magnets, each time they rotate around, there's an electrical field, a magnetic field that induces an electrical potential across the front of the face, and each time the eye shifts, it's moving around. The back of your eyes, all the way at the back of the socket, are negative, South Pole. And the front of the eyes, the corneas, are positive, North Pole. Now, of course, when they move around, they typically move in the same direction, like that. And so there affects some. Now, first of all, if the eyes are sort of going like this, these electrodes won't be affected much. But if they go up or down, these electrodes are going to go crazy. If you want to get horizontal eye movements like that, you've got to put the electrodes, I'm feeling here, on the outside of the eye sockets. Okay? This is called the outer canthus of the eye, a little notch at the end. And in fact, to do eye movement recording, that's where we put them to get the horizontal. So those vertical eye movements are going to be killer. Tell people not to move their eyes around. Well, again, with the meditation, I think that that's going to be a little less of a problem. Probably. It wasn't a huge problem for us with the prior meditation study.
Most people have them closed. We didn't specify one or the other.
And when people have them closed, unless they're dreaming and giving you REM, their eyes are usually pretty still. Even with closed eyes, though, if the eyes rotate under the socket, they'll do that anyway. Now, the last one I said was also an eye movement, and it's the eye blink. Now, the eye blink is a deceptive thing because you think, well, can't I close my eyelids in a blink and my eyes should hold still, shouldn't it? Does your eye hold still when you blink your eyes? Does the eye in the orbit, does it hold still?
Yeah.
Well, the answer is no, but do you know what it does?
Do they roll up a little bit?
They roll up a lot.
Huh.
Okay? So as those lids close in a natural blink, the eyes in the orbit go like this, boop, just like that. It's like you went, look at the ceiling for a split second. Now we can talk about why that might be a useful thing for your body to do, but I have to be honest with you, until I started learning EEG 5 years ago, I'm like 35 when I started doing this, I didn't know that. I've studied visual perception most of my life, and I didn't know that. and yeah, it's a surprising thing, but look at people do this for a fun thing sometime. Do a staring contest and then have that person blink a few times. And what you'll notice is that just as their lids open, you can see the pupils rolling back into place from up high. And that's what they're doing. You can catch the last bit of that little excursion. So what we got to do is we got to try to eliminate body movements and head movements especially. We got to try to eliminate eye movements and eye blinks. Now when they're meditating, it's usually an eyes closed meditation, right? Okay, I'm looking at Jane for confirmation. And that's good because 9/10 of the crap that usually litters the EEG signal that we have to deal with. When we have people playing video games or whatever, it's all gone. And that's nice. It tends to give you cleaner signal. You have one last problem. You got to keep your subjects awake.
Yeah.
I'm here to tell you right now that this is going to be one of the biggest problems. It's going to be totally annoying when you realize 20 minutes into a session that the person is snoring. And that's a big problem, keeping people awake during these things because they're very calm, it's a quiet room, and they're just sitting down, and in a few minutes they're going like that. Their head's going like this or whatever. So you will, in fact, watch your subjects fairly carefully. We might do a closed circuit video link using like a webcam to a computer, maybe, if you're in the adjoining room, or hopefully you've got visual on them directly. But if they do this, okay, that's what you're going to look for. Well, first of all, it'll cause the needles to go crazy. Well, there's no needles anymore, but the waves will go nutsy. And second of all, you'll start seeing things like sleep spindles, sleep phenomena, basically. All right. Well, look, what I want to do is I want to give you a very quick primer on skull anatomy, because we need to know about skull anatomy in order to know where to place the electrodes, okay? Now, you say, well, why do I need to know about skull anatomy when I can't get to the skull? Well, you can feel the skull under that nice rubbery sheet of the scalp, okay? Again, more hair can make it more difficult. But basically, there's two skull landmarks which you have to know how to find. The first one, very easy. It's that little notch at the top of the bridge of your nose. Go ahead and feel it. It's a distinct little V-shaped valley. Okay? This is called the nasion, N-A-S-I-O-N. Okay? Think of that as, I'm not going to call it the North Pole, because this is the North Pole, the vertex of your head. Think of it as sort of on the equator at one point. If your head is a globe, think of it as one point on the equator. And then what we need to do is we need to find the 180-degree opposed spot. Also on the midline, separating the right from left halves, but not all the way down. Now, how are we going to find that? First of all, the name for this thing is the inion, I-N-I-O-N. Now, how do you find it? Well, some people have an inion that's really easy to feel. You put your fingers on the back of their head and you palpate, you just sort of rub up and down, and it'll feel like, I don't know, there's a BB under there or a pencil eraser or something. Do you have an easy one to find?
I have a big old one.
You have a big old inion? Okay. What we're going to do is we're all going to feel each other's inions, because what you'll see is that very quickly there's a lot of variability in this. And you get a room this size with 7 people, sorry, I miscounted. Wait, 7 people and
Stuart.
dog. Actually, I would put money on Stewie having an inion.
Well, I wasn't even going to point out that Stuart was here, but now people are going to wonder what the hell we're talking about when we watch this video. So here is the lab mascot having a nap. And yeah, we can EEG him on some other occasion.
So,
Whoops.
I'm going to give you the instructions for finding the inion on a difficult case. Now, I hope you will follow along with me using your own hands on your own skull. What you want to do is you want to feel behind your head with the whole hand, and you see these two mounds. These are called the cerebellar mounds. They sort of make a little concavity which the cerebellar lobes sit in. You know what the cerebellum is, I hope. Okay? And basically, they make a little humps on either side of the midline, and then they come together in a little low valley. Can you feel that? This is where your skull, by the way, is going like this. It's not quite flat, but it's sort of at a pretty sharp angle. Okay? Just above where you can feel the spinal column coming in, and you'll find those cerebellar mounds. Everybody with me?
Yeah.
Now, when you find that little valley between the cerebellar mounds, all you got to do is go up maybe a couple of finger widths, and if you have a hard one to find, it'll be like a little low ridge. So everybody report to me how easy your inion is to find. We know yours is easy. How about yours, Chris?
Yeah, I think it's pretty easy.
Okay. Jane, how do you think yours is?
Easy.
Okay.
I got a mountain.
Denny's got a mountain. How about you?
It's easy.
Greg? All right.
Yep.
Well, I have a difficult one to find, so we'll practice on me, okay? Now, why is this so important? Well, what you're going to do is you are going to you're going to measure the distance from the inion to the nasion over the top of the midline. This is called the inion to nasion distance, IND. Now, you're also going to measure the circumference of the head. My head, it's about 58.5 centimeters. Chris, you're about 61 and a half, I seem to recall. Here, Chris has a head that's just a little too big for our biggest net. Remember we tried to set
I
you
know
up?
I wear a large hat. I
You
don't
do
remember
wear a
what my
large
measurement is, but I got a big dome apparently.
Head size and circumference scales with body size. So if you're going to sit a guy in the room and he's like this giant football player type, and you just look at that head and it looks like a giant pumpkin, actually, wait a second, what am I talking about? We're not doing the net here. We can do big heads.
I was just about to ask you.
I'm sorry. I don't know what
For
I'm
this
thinking.
project, if we're not using a net,